Good morning, all. Is my screen visible? Okay.
So let's start. In previous lecture, I showed you how to find a path from given pixel P and the end pixel Q, where the path is the set of pixels joining each other, and those all the pixels which we consider for the path should be from the set V. Okay, that is what we have concluded in the last lecture. And I started with this example where we need to find a 4 path and 8 path and M path. And we saw that if I start from this pixel P, go upward, then here there is no 4 path on this side as well as on this side. So here we stuck. If I go to the left, there is only one pixel which is value 1, and we cannot reach this pixel Q from there also. So there also we stuck. But if I go to the right side, I get pixels connecting each other. All the pixels are from the set V, and all the neighboring pixels form a 4 path between them or fourth adjacency between them. So if we go horizontally or vertically to find the 4 path, then that path exists between pixel P and Q, and the length of that path is equal to 7. I think we have counted that yesterday. You have to count the jump between pixel to pixel. So this is one jump, this is other jump, this is third jump, this is fourth jump, fifth jump, sixth jump, and from here to here you reach to the destination in the seventh jump. Then we need to find the eighth path. So for eighth path, there are again same kind of discussions we will have. We should have. We have to look for which are the pixels, neighboring pixels, which form the eighth adjacency. Okay. So again, from this what is available for 4 path will be definitely available for 8 path, because we already know that 4 pixels are pixel adjacent to the center pixel vertically and horizontally, and 8 pixels are pixels which are around the pixel vertically, horizontally as well as diagonally. So 4 path is actually subset of 8 paths. So 4 path will be definitely available, and that will be also counted for 8 path. So for 8 path, what we have, what is shown by the red color, that red line is also a part of a 8 path. So there we have already solved, and we saw that length is equal to 7. Now we will see, is there any other choice for the 8 path? Let me use some other color. So if we go from here to here, then here, then here, then here, nowhere we can go around and reach to the this side, because there are all zeros, isn't it? So the 8 path from right side, the 8 path is only one, and that is already shown by the red color. Let's see if I go vertically upward, if there is any other path available. So if I reach from here to here, then the eighth neighbor is available from here to here, right? So this can be considered. Then from here to here, 8 neighbors are available. So you can see here no 8 neighbor is available. On this side, another again no 8 neighbor is available. But here the 8 neighbor is available, which value is from the set V, right? So we can consider that. Again from here, 8 neighbor is available, and there are two different choices. One is this choice, This way you can reach, or other is this choice. This way you can reach. So there are two different ways. uh, Wait a minute, people are trying to join. Let me allow them. Okay, so as I said, there are two more paths available for eight, using eight adjacency. So that is this one, and the other path is you go from here to here, here to here, here to here, and from here you go straight up and then right, and then destination. So there are two paths, as I said, two eight paths, as I said, which are there when I go vertically upward, and there is one more eight path when I go to the right, which is actually a four path also. Okay, so in the green color path, what are the number of steps required, or what is the length of the path? One, then here to here, two, then here to here, three. Then if I take this inclined path, then this is fourth and this is fifth. So the length is 5. And from here, if I take vertically upward, first, second, third, fourth, fifth, and sixth. So let this six. So there are total three eight paths available in this particular image, and the length of those eight paths is 7, 5, and 6. By using eight adjacency, we have obtained these eight paths. Now let's see how many M paths are available. So let me erase the rest of the things. Okay. So now how many M paths are available? M path is what? M path is you either find whether there is a four path available or not. If four path is not available, then you see if there is a diagonal path available, and at the same time, the diagonal adjacent elements do not have any common fourth element, which is from the set V. So first is to check whether the four path is available. That means you check whether the horizontal or vertical path is available. If horizontal or vertical path is available, then choose that. If it does not exist, then only you go for if there is any diagonal path or not. So first I will go to the right side. I will see that fourth path is available, fourth path is available, fourth path is available, 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 and available. So here we see that what is there for the four path, the same is available for the eight path, and that same path is also available for the M path. Okay, so that is also a M path having length equal to 7. Let's say, is there any other path on the vertically upward? Because here there is no path, we can directly look and comment on that. If there is a path, then that will be going backward and then coming to the right, and this way we do not consider any path, because path is something which is uh, giving us the closest distance between the pixel P and pixel Q. So going backward and then coming back from somewhere, that that does not uh, considered as a path. So let's see if there is any other path available in a vertically upward direction. So here to here, four path is available, and now at this pixel, as you can see, at this pixel, any four path is not available. Here not available, here not available, here not available. So in this case, we have to look for if there is any diagonal path available or not. So let's see if here to here diagonal path is available at this pixel. From this pixel to this pixel, diagonal path is available, and the fourth element of this and fourth element of this has these two common elements, which are 0 and 0, which are not from the set V, and hence we can consider this diagonal path because we don't have any common element in a N4P intersection N4Q, which is part of a V. Okay, so we can consider this path. So from here, any four path available on the left side or right side? No. Vertically upward? Yes. Go ahead. Is there any four path available or left on right? No. Vertically upward? Yes. Go for that. So now you can see from here we see that there is a vertically upward four path is available, and that's why we do not consider this inclined diagonal path. Why? Because there is a priority. Remember, in a M path, this is the difference between M path and Et path. In a Et path, there is no priority. You go vertically, horizontally, or diagonally. There is no priority. But in a M path, there is a priority. If horizontal or vertical path is available, that is to be chosen must. Don't go for diagonal if horizontal or vertical path is available. And if you choose diagonal path, even if vertical or horizontal is present, then that will be considered as a big mistake. Okay, and that will not be treated as an M path then. So here we see that we have a diagonal adjacent element available. We have a vertically upward fourth element also available. Fourth adjacent is also available. So obviously choice should be to the vertical or horizontal path. So vertical is available, choice will be vertical. From here, horizontal number is available. From here, horizontal number is available. So we calculated one M path also, and the length of that is in a blue color 1, 2, 3, 4, 5, and 6. We got two paths of length 7 and 6. So for a 4 path, shortest length path is 7 because there is only one path. For a 8 path, all the available 8 paths, the shortest length path is of length 5, and for the M path, shortest length path is of length 6. So if this is asked, you can comment shortest path in all of the three categories. If it is asked, you can comment. Otherwise, it's not necessary because here it is asked. That's why I commented. Find the shortest 4 path, shortest 8 path, and shortest M path. So we have to comment which one of all the possibilities are shortest among these three cases. Okay. So this example is discussed in a YouTube video whose link is provided here, and I suggested you look at the video. I provided that link in a WhatsApp as well as in the chat box yesterday. So if you have seen, you might have got an idea. Otherwise, you just go and look at that video once again. After that, boundary. Boundary is the region R, which is the set of pixels in that region that have.
तू फेल लेना हुआ गोतार क्योंकि तेरे यहाँ पे F बता रहा है
Shikha, if you are not interested in lecture, you can leave it and you can discuss the rest of the things. This is not mandatory. You have a privilege of looking at the. You have a privilege of looking at the video lectures or not looking at the video lectures and sending a message that I have watched this video. That will count your attendance, and that is what is necessary for you.
No, sir. Actually, I was. It is the first message I was trying to join the class.
Then.
सर एक्चुअली वो गोताड़ का थोड़ा प्रॉब्लम हो गया है उसका पॉइंटर दिखा नहीं रहा तो उसका कॉल आ गया था दैट्स व्हाई सॉरी सर इट इज माय मिस्टेक
इट्स ओके so here boundary is the set of pixels that have one or more neighbors that are not in the region R. For example, suppose I sketch an image like this, and suppose this is some other region in that image. So if I discuss on this region, suppose any pixel which is here, listen very carefully. Suppose there is a one pixel here at this position, then some of the neighbors of that pixel will be in this region here on this side, and some of the pixels or some of the neighbors will be here in some other region. Okay. Similarly, if I consider some other pixel here for example, some of the neighbors will be the part of that region, and some of the neighbors will be outside of that part of the region. So this kind of pixels which are having some neighbors as a part of that region and some neighbors as a part of some other region are called as a boundary for that particular region. I hope you understood the meaning. So for example, if I show you some image, maybe this image, you can see this black rectangle shape. So if I consider a black pixel which is situated here, then some of the black pixels are the neighbor on this side and some white pixels are the neighbor on this side. So this kind of black pixel which is under consideration, having some of the neighbors part of the black region and some of the neighbors part of the white region, and this kind of pixel is called as a boundary pixel. And collection of all such boundary pixels will give us the boundary of an image or boundary of that particular black region. So as per definition, it is a set of the pixels in which one or more neighbors should have the one or more neighbors uh, should have to be from the region, and some neighbors should have to be from outside of the region. Such pixels are called as the boundary. If R happens to be an entire image, means what? If region is the entire image, then the boundary is defined as the set of pixels in the first and last rows of the rows and columns of the image. So for example, suppose region is this complete image, then what will be the boundary? Boundary will be the border of that image. That means the first row, last row, first column of pixels and last column of pixels. That is nothing but the boundary. So in this case, border of an image is nothing but boundary. If there are two sections, one is filled with white color and other is filled with say black color, then the boundary is set of pixels which are the border of a black side and set of pixels which are border of the white side. So when I consider boundary, as you can see, the pixel just on the right side, the black pixel just on the right side is a part of a boundary, and the pixel which is just on the left side it is a part of a white boundary. So you can see at the boundary what happens, pixels change from white to black, pixels change from white to black. So there are two different boundaries. One is the part of a boundary for the black side and other is a part of a boundary for the white side. Then foreground and background. An image contains k disjoint regions. Means suppose this is an image, it will have some object here, some background on the back side filled with complete border. There is a background and there are three different objects like this. So there are multiple regions, RU, R1, R2, R3, R4. So in this case, R1, R2, and R3, three regions. The union of all the k regions and complement of that will form the foreground and background. So if I talk about union of these three main part or main regions, which is this, and this. So union of these three regions is called as a foreground, and the complement of that means what? What is left in the background after leaving this area, and this area. After leaving these three area, what is left in that particular image is called as a background. So union of all the regions of interest is foreground, and complement of that union, that is what is left in the image, is called as a background. And we basically know what is foreground of an image and what is background of an image. Suppose a person is standing on a beach, then the sand and beach forms the background and the person who is standing, who is photographed, is called as a foreground. Okay, so like that. You can have a look at these examples, question 1, question 2, and question 3, and the same has been discussed here in this particular slide. So you can just have a look and you can try to understand. If you have any difficulties, you can ask me. Okay, this is for your understanding purpose. Then we have distance measures. If we are given with pixels p, q, and z with coordinates x comma y, pixel p has a coordinate x comma y, pixel q having coordinate s comma t, and pixel z having coordinate u comma v, then the distance function will have the following properties. The distance between p and q, distance between the pixel will be always some positive distance or zero distance. So if pixel p and q are same, that means if I'm finding distance of a pixel from itself, obviously that distance will be 0. So distance of p to q is 0 if we are finding a distance between the same pixel with itself. Okay, so in general distance cannot be negative, because distance is we always know what distance is. Distance is the separation between two elements, and that cannot be negative. Even if those elements are overlapping, the distance will be 0, but it cannot be negative. So distance between A to B and distance between B to A is always same. These are the general properties. These are not any different properties. If we have one element here P, another element here Q, sorry, one element here, wait a minute. If there is a one element here P and the other element here Q, then the distance, or let's say this is Z. Let's say this is Z for this example. Then distance from P to Z is less than or equal to. So let's say there is another element Q here. If you find the distance between PQ and distance between QZ, so this is the distance between PQ and this is the distance between QZ, then that addition of distance between PQ and QZ will be always larger than the straightforward distance between PZ. Okay, because if you take any Q element, suppose Q is here and distance between PQ is this, distance between QZ is this, still the distance between PQ and distance between QZ, the addition will be larger than direct distance between PZ, because they are on a straight line. So the direct distance between two elements will be always less, or the shortest distance, if we go from any other path to the pixel Z. So from P to Z, go directly, you will get shortest distance. If you move from P to Q and then Q to Z, then wherever that Q may be, the distance will be always larger as compared to the direct distance. Okay. So these are the three different distance measures which are used in the image processing. How we identify the distance between two pixels. One is called as Euclidean distance. It is represented by D Euclidean, DE, between P and Q. It is x coordinate difference square plus y coordinate difference square, the square root of that. That means square root of x minus s the whole square plus y minus t the whole square. And that is what is written here. Square root of difference between x coordinates of P and Q the whole square plus difference between y coordinates of P and Q and then whole square. So as you are taking the difference and then you are squaring up, it doesn't matter whether you are performing s minus x or x minus s. Here also it doesn't matter whether you are performing y minus t or t minus y, because the term is getting squared and hence it will be always positive. This will be always positive and the square root of that will be also positive. Another kind of a distance is called as city block distance, D4 P comma Q. So it is using fourth neighbors. So it is calculated as x minus s the mod of that plus y minus t the mod of that. So it is in general the distance which is calculated in this way. Suppose pixel P is situated here, pixel Q is situated here, Then Euclidean distance will be the direct distance between these two. This is suppose pixel P and this is suppose pixel Q. Euclidean distance is the direct distance, that is the length of this line. This line will be the Euclidean distance in general. And the city block distance is the distance between P and Q, where x minus s, that is you find the difference between x coordinates, you find the difference between y coordinates, and you add them up. So the basically what you will get is a this plus this. That length is nothing but a city block distance. So basically you need horizontal and vertical line to connect between pixel P and Q, and that's why it is called D4. That is, you are using fourth neighbors to join between P and Q to find a distance, right? Third is a chessboard distance. Chessboard distance means you just identify how horizontally they are separated or how vertically they are separated, and the maximum of that is called as a chessboard distance. So suppose this is 5, vertically P and Q are separated by 5 units, and horizontally they are separated by 6 units. So maximum of horizontal distance or vertical distance, the maximum of that is called as a chessboard distance. So in this case, chessboard distance is 6. In this case, city block distance is 6 plus 5, that is 11. And in this case, the Euclidean distance is square root of 6 square plus 5 square, that is 36 plus 25. Square root of 36 plus 25. Okay, hope you understood. And it is having the same coordinate uh, Cartesian coordinate standards that we use in the general graphs. Okay, it is not using anything new. So as you can see, there is an example image. Let me erase the rest of the things. There is an example image where the center pixel is 0, and some of the pixels are filled on the right side, and you can find out the distance between the pixels. And I think I missed that slide. Okay. In the following arrangement of pixels, what's the value of chessboard distance between the two circled points? So can you find chessboard distance between this element and this element? Hope you remember what is chessboard distance, the maximum of horizontal separation and vertical separation. So what is horizontal separation here? Horizontal separation is same as vertical separation. So in this case, the chessboard distance is same, and that is 2 units. So here to here 1 unit, here to here 2 units. Similarly, here to here 1 unit, here to here 2 units. So vertically they are 2 units apart. Horizontally also they are 2 units apart. So maximum of 2 comma 2 is 2. Then the city block distance. Can you find the city block distance? Horizontal plus vertical, that is 4 units. Array versus matrix operation. I hope you remember when I multiply array A with array B, I use dot star notation. Dot star represents element by element operation. So it is product performed on element by element. So A11 multiplied by B11, A12 multiplied by B12, A21 multiplied by B21, and A22 multiplied by B22. This is called as array product. And the simple matrix product, we all know how to do that. There we use the representation of only A star B, where the matrix A and matrix B are multiplied. I hope you remember matrix multiplication. First row is to be multiplied with first column. That will give you this one element. Then that same first row multiplied with second column, that will give you this. Then the second row multiplied with first column will give you this, and that second row multiplied by second column will give you this. Okay. And dot star is an array product operator, and matrix product operator is only star. So we don't want this. two more things are remaining, that is color models. So representing color can be seen here. As you can see, if I use red color at the intensity of 255 and 255, green color at the intensity of 255 and 255, and blue color at the intensity of 255 and 0, the resulting colors will be this. So meaning of this is, if I use red color at the highest intensity, that is 255, green color at the highest intensity, that is 255, and blue color at the highest intensity, that is 255, the resulting color will be 5. So as you can see, red, green and blue mixed together results in a white color, which is shown at the center. Uh, and that you can easily understand by looking at the image. So it is actually additive color model, and we will be considering name of this as a RGB color model, red, green, blue color model. In the same way, if I use red color and green color, if I use red color and green color, what is the resulting color that you can see here? Red and green, the resulting color is yellow. So if I use zero intensity of a blue color, and if I only mix red and green, the resulting color is yellow color. Okay, and this additive color model can be best visualized uh, in the next slide. Next PPT I will show you, sorry, PDF I will show you how to do that. So basically what is done is, a pixel is passed through the red filter, which has uh, 8 bits to be stored for the red data, 8 bits to be stored for the green data, and 8 bits for the blue data, RGB. So 8 plus 8 plus is 24 bits for representing a single pixel with color as well as intensity. So when I pass through the red color filter, the resulting data, uh, and the green filter, the resulting data, and the blue filter, the resulting data. If I combine all of these three, the pixel can be again produced on the screen. So I hope you remember what I told you, that if I use larger number of bits, the intensity levels can be more. So if I use 8 bits to represent the data, then I can have 256 intensity levels. That means they vary from 0 to 255. These are the number of intensity levels, 0 to 255. Okay, so let's have a look at the PDF color models. So in this PDF also, the distance measures have been shown, as you can see here. Various other things that we learned, those are also listed. I will be sharing with you this PDF. And this is other PDF in which the color models have been discussed. So these are the different color models: RGB, CMYK, HSV, and YIQ. These are the different color models. Let me open this PDF through Microsoft Edge first. Color models. Okay. So in the first RGB color model, as I said earlier, it is a additive color model. As I said, there are addition of three different colors, red, green, and blue, to form all the other colors which can be perceived by the human eye. So by using these three primary colors, we can literally make any other color by using the different proportions of these three colors. So these are three channels RGB. This is used in digital image processing using OpenCV Python programming, and it is used in online logos and many other applications. What intensities of red, green, and blue makes to the resulting what color has been shown here in the uh, diagram that is shown here. So this side is a red color, this side is a green color, and this side is a blue color. If you are at the center of the coordinate system, that means you are mixing red, green, and blue at the zero intensity. If you are at this point, coordinates of these are 0, 1, and 0. That means you are not using red, you are using green to the fullest intensity, and you are not using blue color. So this is green color. So on this axis, it is a green color for varying intensity. At this point, green color of the maximum intensity, that is 255 intensity. Similarly, uh, bright blue to dark blue, bright red to dark red. So at this point, what is basically I am mixing? I am mixing dark red color with dark green color. I am not using any blue color, and the result will be yellow color. And that you can see here also. I am using dark red with dark green. The result is yellow color. I am not using any blue color. If I add same proportion of blue color, that means I have to, blue color means vertically upward. So if I add same proportion of blue color, if I go vertically upward, then the resulting color will reach towards white. So to have clear understanding of that, I have included one link here. You can go and click on that link. Where is hand tool? Mhm. Wait a minute. You can click on this link. It will ask that you are getting redirected. Okay, no problem. Open that, and here you can visualize whether what we are discussing is correct or not. So this is a red, this is a green, and this is blue. The box represents the intensity that we are using. So currently, let me use zero intensity red color, zero intensity green color, and zero intensity blue color. Do you see that black color has been formed by using RGB? If I use full intensity blue, full intensity green, that is some cyan color, cyan color. Okay, so this is not primary color, this is a resulting color by using these three primaries. If I add some redishness, as you can see very easily, if I keep on adding some redishness, the cyan color will become eventually faint. It will reach more and more brighter side, and at the highest intensity of red, I have white color. So that is what we learned in the representation here. If we use zero intensity, if we use largest intensity of red, largest intensity of green, and largest intensity of blue, the resulting color is white, as you can see here on top, white. So that is what we formed here. You can play around with this website, and you can form many other colors. If I use 128 intensity of red, 128 intensity of green, and largest intensity of blue, then I will be having some color uh, which is not exactly the primary color, but some resulting color. So likewise, you can play around and you can form many other colors. As we saw, red and green is yellow, so you can verify that also. Red and green is yellow with no blue used, like this. Okay, so this is one color model. There is another color model which is called as CMYK. Can, C stands for can, M stands for magenta, Y stands for yellow, and K stands for key, that is a black. So this is subtractive color model. The meaning of this is when you subtract RGB from 1, you get CMY color model. Okay, so its image is also shown here. You have to remember this. Can is a negative of red, magenta is negative of green, and yellow is negative of blue. What you get here, I close that or what? Okay. Okay, so if I reverse this all, I reverse this all, I get blue. So what is written here? Yellow is negative of blue. So earlier I had yellow when I mixed red and green to the fullest and no blue, it was yellow. When I reversed everything, red 0, green 0 and blue maximum, I got blue color. So it is actually a subtractive color model. When you subtract or you make negative of everything. Negative of everything means what? 1 minus the current color. That is called as a can color model. So here in a can color model, you have negative of red, negative of green, and negative of blue. And you can see here can and magenta and yellow. These are primary colors, and the resulting of that is a green, blue, and red. So green, blue, and red can be formed by using can, magenta, and yellow now. Now green, blue, and red are not primary colors in CMYK model. I hope you are understanding. So this kind of model is used in kind of printers and other applications which are not digital displays. And this kind of RGB color model is used in other applications such as DIP processing, OpenCVs, in online logos, and so on. The third model is HSV model. HSV stands for hue, saturation, and values. See, these are just introduction to the digital image processing. That's why we are learning only the overview. The red color falls between 0 and 60 degrees. So you will have to use some angles like this. Suppose this is 0 degree. This is 60 degree. Then this is 120 degree, 180 degree, and so on. So in the first cone of 0 to 60 degree, there will lie a red color. In the second cone from 61 to 120 degree, there will lie a yellow color. Oh, sorry, yellow color. In the third cone of 121 to 180 degree, there will lie a green color. Let's use green color like this, and so on. And this kind of model where total 3 plus 3, 6 colors are used as a primary colors, and the saturation means hue means the color, saturation means the depth of that color, that means how green it is or how red it is, that means the saturation, and the value means the intensity of that color. So that has been described here. The percentage of color is represented with the help of saturation. Its value is between 0 and 1. 0 means uh, deepest green, 1 means the brightest green. Saturation describes the gray color, grayness, and the value represents the intensity, as I said earlier, the how bright or how white, how dark it is. So primary color is a dark green, and its intensity may vary from 0 to 250 pi. Primary color can be bright green, and its intensity can be varied between 0 and 250 pi. So I hope you understand what I am talking about. The saturation itself can be one parameter that has been divided into 255 intensity levels. So initially you use the dark green and you divide that into 255 intensity levels. This will give you one kind of color. Initially you use brightest green and you use division of that into 255 levels. So you can imagine how many number of intensity levels of that green you can have. So this is the cone that I was discussing about. 0 to 60 degree, there was a red color, as you can see. 60 to 120 degree, there was a yellow color, as you can see here. 120 to 180, green color. 180 to further 60 degree, there will be the can color, then the blue color, and then the magenta color. Can color, and then the blue color, and then the magenta color. Okay. Last model is YIQ model, where it is used in television broadcasting. The Y stands for luminance part. Luminance is nothing but uh, only the grayscale intensities, and YIQ, the IQ stands for the chrominance part. That means the color value. So for black and white television, only Y part is transmitted. That is only grayscale data is transmitted. And for color television, along with Y, IQ is also transmitted. That means the color information is also transmitted. So there exists a formula to convert RGB image or RGB data into YIQ data and vice versa. So these are the formulae for that. If you have RGB colors, you multiply them with uh, these matrices to get the YIQ, and the reverse is also true. If you have YIQ image, you multiply with this matrix, you will get the RGB color information. The last part from this particular module is how image is getting stored. So for that, we have different file formats for the image, such as BMP, JPEG, and TIFF file format. And I suggest you go through that, because only the uh, basic information is needed. You read these 3 paragraphs and you will get to know what are these file formats, okay, and how image is getting stored using these 3 file formats. I will be sharing with you this PDF document, and with this, actually, I declare that we have finished with our first module. Actually, it needed 4 lectures, but we finished in almost 6 lectures. So we will start with the second module in the next lecture. If anyone has any doubt, he or she can ask. If you have no doubts, you can leave. Thank you.
सर
Yes.
सर ते सिटी ब्लॉक्सचं आणि चेसबोर्डचं एकदा दाखवा ना.
दाखवू का? हा, इथे आता समजा ही इमेज दाखवली ना मी, तर इथून सिटी ब्लॉक डिस्टन्स समजा काढायचं आहे, इथून या पिक्सल मधलं सिटी ब्लॉक
Yes,
डिस्टन्स
sir.
काढायचं आहे. तर हॉरिझॉन्टल
Yes.
डिस्टन्स आणि व्हर्टिकल डिस्टन्स जेवढे असतील ना, त्यांच्यामध्ये ते ऍड करायचे. समजा एक पिक्सल इथे असेल आणि एक पिक्सल इथे असेल, सिटी ब्लॉक डिस्टन्स काढायचं आहे. सिटी ब्लॉक डिस्टन्सचा अर्थ काय, लाईक हाऊ डिफरंट ब्लॉक्स आर अरेंज्ड इन अ सिटी अँड हाऊ वी ट्रॅव्हल देम. कसे ट्रॅव्हल करतो आपण? सरळ स्ट्रेट पाथ तर कधी असत नाही ना सिटी ब्लॉक मध्ये, आडव्या आणि
हो.
उभ्या लेन्स असतात. मग तसंच इथे तुम्ही असं जा, असं जा, असं जा, असं जा, असं जा, असं जा, ते डिस्टन्स, आणि असं गेलात आणि असं गेलात ते डिस्टन्स ते सेमच येणार. सो कोणत्याही वेने यूज ओनली हॉरिझॉन्टल अँड व्हर्टिकल पाथ and you calculate that distance, that is called as a city block distance. So the shortest
Okay.
way to find that is use coordinates of a first pixel. Let's say this is x comma y, and coordinates of a second pixel, like this pixel, let's say this is s comma t. So x coordinate काय आहे याचा? x आहे, याचा s आहे. You
Yes.
find the difference between x minus s, that will give you the horizontal separation between those two. Then you find the separation between y and t by using y minus t, that will give you vertical separation.
Vertical separation.
And you are only interested in a separation. ते कोणता पिक्सल वरती आहे कोणता पिक्सल खालती आहे याच्याशी काही मॅटर करत नाही ना, म्हणून ते
Yes, sir.
मॉड साइन घेतलंय इथे. मॉड साइन घेतलंय का? कारण फक्त सेपरेशन हवंय. एक्स कॉमा वाय वरती आहे की एस कॉमा टी वरती आहे हे आपल्याला काय नको आहे. आपल्याला फक्त व्हर्टिकली ते किती सेपरेटेड आहेत ते डिस्टन्स पाहिजे, म्हणून आपण मॉड घेतलाय.
ओके
मग
सर.
ते व्हर्टिकल सेपरेशन काढायचं, हॉरिझॉन्टल सेपरेशन काढायचं आणि ऍड करायचं. दॅट विल गिव्ह यू अ सिटी ब्लॉक डिस्टन्स. आणि चेसबोर्ड डिस्टन्स मध्ये काय आहे, तसंच करायचं. एक्स मायनस एसचं हॉरिझॉन्टल सेपरेशन काढायचं, वाय मायनस टी व्हर्टिकल सेपरेशन काढायचं आणि त्याच्यातला जो मॅक्झिमम असेल त्याला आपण चेसबोर्ड डिस्टन्स म्हणायचं. म्हणजे चेसबोर्ड वरती जर त्यांना ठेवलं तर ते एकमेकांपासून किती सेपरेटेड दिसतील, हॉरिझॉन्टली किंवा व्हर्टिकली. त्याच्यात जे मॅक्झिमम असेल ते म्हणजे चेसबोर्ड डिस्टन्स. आलं लक्षात?
येस सर.
Okay.
येस सर, आलं. थँक्यू सर.
ओके, वेलकम.